Welcome back. Today we are going through lesson 6-8, which is all about the zeros of polynomials and finding all of them. So at this point, we've learned a lot about polynomials, and we are going to kind of put it all together in this lesson. So the first thing that we need to know is something called the fundamental theorem of algebra. So the fundamental theorem of algebra says that every polynomial equation that's equal to 0 with degree that's greater than or equal to 1 has at least one root. That root is either a real or a complex root. The way we use the fundamental theorem of algebra is that we look at the degree of the polynomial, and we know that the degree matches the number of roots. So for this polynomial in number 1 here, we can see that it's a third degree, so that means that it has 3 total roots that we would need to find. If we look at the second one here, we can see that it's 4th degree, so I would need to find 4 roots for that one. So that fundamental theorem of algebra is what we are going to use to start solving. Let's go through the steps to finding all of those different zeros. So step 1 is to use the degree again. So we're going to use that 4th degree to determine the total number of zeros we need to find. So we need to find 4 total zeros here between real and complex. So step 2 is using the rational root theorem, which we've talked about before, to identify all the possible rational roots. So remember the rational root theorem, we take the factors of p and q, and we figure out what they would be. So in this case, we're going to take all the factors of 20 and divide it by all the factors of 1. So we would have positive and negative 1, positive and negative 2, positive and negative 4, positive and negative 5, positive and negative 10, and positive and negative 20. So those are all the factors of 20 divided by all the factors of 1. And those are all my possible rational roots. So then we use the remainder theorem, or you can graph the polynomial to find at least one of the rational roots. So you would see where the root or the x-intercept is on your graph. And we would use that to start our process of finding those. So the first thing I know is that 1 is going to be a 0 of this function, or a root of this function. So I'm going to use synthetic division to give myself a simpler polynomial to solve. So when I do that, I drop the 1 down, I multiply and add, multiply and add over and over again until I see that remainder of 0. So remember that remainder of 0 tells me that x minus 1 is one of the factors that I have, and this polynomial that's left over is now something that I can factor. So we're going to factor that remaining polynomial now. So remember, we've divided out 1x, so now I've dropped down to x to the 3rd power plus 5x squared plus 4 plus 20. So we use these up here to write our new polynomial. So we can factor that remaining polynomial, or we can use any of our other methods that we know in order to do that. So for this one, I'm actually going to divide out another 0 that I saw on the graph when I graphed it. So the graph of this function also crosses at -5. So I am going to go ahead and divide that out of my new polynomial, since I know another rational root. So again, we're dropping down, then we multiply and add, multiply and add. And I can see that that remainder is 0 again, so that tells me that that is another factor. And now I have a quadratic that's left here. So the quadratic that I have left from here is x squared, because again, we went from x cubed, we divided out another factor, plus 4 equals 0. So now I'm down to a quadratic, and I can solve a quadratic that's simple like this by just isolating the x. So that's going to leave me with x squared equals -4. And I know that when I square root both sides, I get x equals plus or minus, because we took the square root when solving. And then the square root of a -4 is 2. So once we have that, now we can kind of write all of our factors together here. So if you remember from step 3, we used the graph to figure out that 1 is a solution. So that means that x minus 1 is the factor that it comes from. And then we also used the graph in step 4. That gave us a solution of -5. So that means I have a factor of x plus 5. And then we know from up above in step 4 that x squared plus 4 is the non-factorable quadratic that was left over in there. We can also write that. So keep the real factors the same. And then we could also write that x squared plus 4 from our solution. So we could say it's x plus 2i and x minus 2i. So either of those would be the factored form. And then the last step here is to identify all the zeros. So I know that the 0 that comes from x minus 1 is at 1. The one from x plus 5 is -5. The one from x plus 2i is -2i. And the one from x minus 2i is positive 2i. So those would be all my solutions, real and complex, to the original 4th degree polynomial that we started with. So those are the 6 steps that we're going to use to find all the zeros, real and complex, for any polynomial we come across. We're going to look at 2 more examples here, just to kind of help us practice. So again, we're going to go through those same steps, and they're written there for us again. So the first thing we're going to do is we're going to find how many zeros we need to find total. So we use that degree. So with this one, we need to find 3 total zeros, real or complex. So we're going to find the possible roots. So we're going to take the factors of 9 and divide it by the factors of 2. So when we do that, we get plus or minus 1, plus or minus 3, and plus or minus 9. So those are all the factors of 9 that are divided by 1. Now, since 2 is also a factor of 2, I'm going to take all those factors of 9 and divide them by 2. So those are all the possible rational roots that we could find. So then again, use a graph, use whatever you need to find a root. So if I graph this one, I can see that it crosses the x-axis 3. So 3 is a solution that I am going to divide out using synthetic division. And again, when I do that process of multiplying and adding, I figure out that indeed the remainder is 0 there, so that is a factor. And that is going to leave me with my coefficients for my new polynomial. So remember, we were at 3rd degree in the original problem. We've divided out a factor. So now we're down to 2x squared minus 5x minus 3. So for this one, I'm down to a quadratic. We can use any of the strategies we've talked about. You could do the quadratic formula. I'm going to go ahead and factor it using that slip and divide method that we've talked about before. So I'm going to multiply these together, and I'm going to get x squared minus 5x minus 6, so that I now have a quadratic with a leading coefficient of 1. So I'm going to factor that. And the 2 numbers that multiply to -6 and add to -5 are -6 and +1. So those are my 2 factors. And then remember, I multiplied by 2, so now I need to divide that back out. And when I do that, I get x minus 3 here, because 6 divided by 2 is 3. 1 is not divisible by 2, so I'm going to slip that 2 out in front, so that I keep that factor at -1/2 as a solution. So now I've got linear factors. I can write the whole thing out. So remember from step 3 up above that we knew 3 was a solution based on our graph. So we had a factor of x minus 3 for that solution. We also had an x minus 3 in this factored form. And then we had 2x plus 1. So what we notice here is that this x minus 3 factor is happening twice, we call that a double root. So when we think about the solution for that one, we only need to write it once. So that x equals 3 is one solution. And then for the other solution, 2x plus 1, that would be a solution of -1/2. So those are my roots. Now again, if you look back up at the beginning, we said we needed 3 solutions. That 3 counts twice. So we still have 3 roots there, even though we only listed 2 numbers. We have a double root at +3. Okay, let's look through one more example here. So for this 4th degree polynomial, we know that we're going to have 4 zeros. So let's go through all of our possible roots here. So this one, we are looking at the factors of -8 and dividing them by the factors of 1. So if I divide, of 5. So one of the factors is 1. So all the factors of 8 divided by 1 would be 1, 2, 4, and 8. And then all of those factors divided by 5, because that's the other factor of 5, would be 1/5, 2/5, 4/5, 8/5. So 8 possible rational roots there that are also plus and minus. So then we're going to go to the graph and find any of the roots I can see on there. If I graph this one, I can see that there's a solution at 1. So I am going to divide my polynomial by that 1. So I have a 5. I'm missing an x to the 3rd term in my original polynomial, so I put in that 0 as a placeholder. And then 3, I'm also missing an x term, and then my constant. So when I divide these, I drop that one down, and then I multiply and add, multiply and add, multiply and add one last time, and we get that remainder of 0 that we need. So we know that 1 is indeed a factor. Now I'm still left with an x cubed here, right? So if I rewrite this polynomial, it's 5x cubed plus 5x squared plus 8x plus 8. So that is still a 3rd degree polynomial, which I could potentially factor, but I can also use my graph and see if there's another real root that I can see. And for this one, I can see that it also goes through -1. So I'm going to go ahead and divide that out to get a simpler polynomial to factor. So I'm going to do my synthetic division again. Doing the process over again. Did not mean to write the x there. We just write the coefficients. And again, we get a remainder of 0. So that means that -1 is a root of this polynomial. So now I'm left with 5x squared plus 8. And that is a quadratic that I can again solve simply. So I'm going to subtract 8 from both sides. And I'm going to get 5x squared equals -8. Divided by 5. Get x squared equals -8/5. And then I just have to square root both of those. So I'm going to write it over here. I get x equals, I took a square root when I'm solving, so I'm going to put a plus or minus. And then I have a few things to look at here. So the square root of 8, I know that that simplifies to the square root of 4 times the square root of 2, which is 2√2. And it has a negative out in front. So I'm going to write that as 2i root 2. So the square root of 8 simplifies 2i root 2. Then on the bottom, I still have a square root of 5. And remember, we don't want to write our answers with a square root in the denominator. So I'm going to multiply both of these by the square root of 5 to rationalize the denominator. So when I do that, I get plus or minus 2i root 10 now over 5. So when I write my final factored form, I know from step 3 that x minus 1 is a factor. I know from step 4 that x plus 1 is a factor. And then I also know that 5x squared plus 8 is the factor that remains that we can't simplify any further. So then my solutions are positive 1, negative 1, and then we know from here that we have, let's write them separately here, that we have 2i root 10 over 5 and negative 2i root 10 over 5. So those are our 4 zeros, 2 of them real that I could see on the graph, and 2 of them complex that I found using algebra. We'll see you next time.